Welcome to the AI Checkpoints.
And just a quick note before we get started, the discussion today is generated by AI, based on the source material provided.
Exactly. So today, we're doing a deep dive into something really practical, I think. It's all about bringing real observability to AI coding assistance. Specifically, we're looking at Claude Code.
Yeah, and we're drawing heavily from this article, Bringing Observability to Claude Code, OpenTelemetry in Action, by Gautam Karthi over at SigNoz. The goal here really is to take these AI tools out of the black box.
That term, black box, it really hits home, doesn't it? For platform engineers, for, development leads. You feel like tools like Claude Code are helping, but proving it, measuring it, that's tough.
It is tough, and Karthi's point in the article is spot on. Without monitoring, you're kind of guessing about the ROI, about productivity gains, even about basic stuff like system reliability. You're flying blind.
Flying blind when these tools are becoming, well, pretty central to how developers work. It's not just a nice-to-have anymore.
No, definitely not. So if they're unreliable or if the costs are hidden, that's a big problem.
Okay, so let's unpack why monitoring is so vital here, according to the source. It's more than just seeing login counts, right? What are the actual business questions we need answers to?
Right. The article lays out several key areas. First, the obvious one, money. You absolutely need to know your total token usage. And critically, what does that actually cost in dollars?
Because these things aren't free, pay-per-use can add up fast if you're not watching.
Exactly. Budgeting becomes impossible otherwise. Then there's the operational side, like adoption. Are people actually using it effectively?
So not just logins, but like how many sessions, how many conversations per user, how many requests, trying to see if it's really embedded in their workflow.
Precisely. Is it deep usage or just surface level stuff? And tied to that is maybe the most critical operational point the source mentions, quota visibility.
Ah, okay, like hard limits.
Yeah, exactly. Claude Code, for instance, has this 5-hour rolling quota. If you don't track your team's usage against that limit, well, developers could suddenly get blocked right when they need it most.
Ouch. Mid-deployment, maybe? That's not just annoying. That stops work cold.
It really does. So monitoring turns that potential crisis into just, a resource you manage proactively.
Yeah.
It's about prediction, not reaction.
Makes sense. What else? Performance?
Performance is huge. Things like command duration, how long are developers waiting, and the overall success rate of requests. If it's slow or fails often, developers will just stop using it no matter how smart the AI is supposed to be.
Yeah, frustration is a killer for adoption. And the source mentioned behavioral insights too.
Right, like which terminals are people using it in?
Right.
VS Code, Apple Terminal, that tells you where the integration is working best. And what kinds of tools within Claude Code are popular? Does that tell us where we should focus training, maybe?
Okay, that's a lot of granular data points, quotas, costs, tool types, success rates. How do we actually get all this information out in a consistent way? That's where the observability-powered duo comes in, right?
Exactly. The first part of that duo is OpenTelemetry.
OTel.
Right, the open source standard
Yeah.
CNCF project. Big deal in the observability world.
Huge deal. Its whole purpose is to standardize how we collect telemetry traces, metrics, logs from our applications. And the key advantage, which Karthi really stresses, is instrument once, export anywhere.
Meaning you use OTel to get the data out of Claude Code, things like request times, model usage, success failure, and you're not locked into one specific monitoring vendor to see it.
Precisely. OTel provides those standard hooks.
Yeah.
The OTel is just the collection agent, right? It gathers the raw data. You need somewhere to send it to make sense of it all.
And that's where SigNoz fits in, according to the article. Yep. SigNoz is presented as the all-in-one observability platform. It takes that stream of OTel data and acts as the analysis and visualization layer. It turns the raw signals into dashboards, alerts, actionable information.
So OTel collects, SigNoz analyzes, and visualizes. Got it. Let's talk about the actual signals then. What kind of data are we looking at? Starting with metrics.
Okay, yeah. Metrics give you the numbers, the what, and how much.
Yeah.
Super important for leadership making decisions.
So the first ones have to be about cost, I imagine.
Absolutely. The article highlights claudecode.cost.usage that gives you cost per session in actual USD,
Right.
and then claudecode.token.usage for the raw token count. You need both.
Can you get that granular, track cost per developer, maybe?
You need to, yeah, for forecasting and accountability.
Right.
But then it gets really interesting when you link AI usage to actual code output.
Yeah.
Metrics like claudecode.linesoftcode.count, claudecode.pullrequest.count, and claudecode.commit.count.
Ah, okay. That's the connection to tangible results. Is the AI actually helping ship code or just generating a lot of tokens? Linking usage to PRs, that feels like the proof point for ROI.
It really is. Otherwise, you just see a big bill and wonder what you're getting.
Yeah.
But for me, one of the most insightful metrics tracks engagement and, maybe more importantly, developer trust.
Trust. How do you measure that?
Well, you track session counts. ClaudeCode.session.count, sure.
Yeah.
But look at ClaudeCode.code editTool.decision. This logs if a developer accepted or rejected an AI code suggestion.
Oh, wow. Okay. So if they reject a lot of
It
suggestions.
tells you something important. Maybe the suggestions aren't good enough, maybe the prompts are bad, maybe the model isn't suited for the task. But if they're rejecting, say, 70% of suggestions from an expensive model, that's a huge waste and a signal that something's wrong. It measures efficiency beyond just usage.
That's a really powerful point. It's about quality of interaction, not just quantity.
Exactly. And you also track ClaudeCode.activetime.total. How long are developers actively engaged in a session? Longer times suggest deeper reliance.
Okay, so metrics give us the numbers, but the source also talks about logs providing the story, the narrative behind those numbers.
Yeah, logs capture the step-by-step interaction. The article details a few key ones. It starts with ClaudeCode.userPrompt. This logs when a user submits a prompt, its length, and optionally, the prompt text itself.
If you enable it, right. Using that environment variable, OTELA user prompts 1. That seems useful for understanding what developers are struggling with or asking about.
Super useful for tuning training, or even the AI's instructions. Then there's ClaudeCode.apply request. This logs every single backend API call, which model was used, the cost of that specific call, how long it took, token counts for input, output, even cache usage.
That sounds like the bread and butter for debugging performance and cost per interaction.
It is. And for reliability, you need ClaudeCode.apr. You have to log failures, the error messages, retry attempts, essential for keeping the tool stable.
Makes sense. What about the tool usage logs?
Right, so there's ClaudeCode.toolResult and ClaudeCode.toolDecision. These track if a specific tool command, like reading a file or running a bash command, succeeded, and then if the developer actually accepted that result.
Ah, closing the loop again. Did the AI do the task, and did the developer trust the outcome enough to use it?
Exactly. It measures the reliability of specific AI actions, not just the chat.
Okay, so we've got all this rich data, metrics, and logs flowing via OTel into SigNoz. Now, the crucial step, turning it into something actionable. Dashboards. What are the must-haves for, say, an engineering manager listening right now?
Yeah, visualization is key. The article suggests several practical dashboards. Number one, non-negotiable. Cost control. A big panel showing total cost in USD. That's for ROI validation and spotting any sudden, unexpected spikes in spending.
Like a runaway process or something. Good safety net.
Definitely. Then quota management, specifically tracking that 5-hour rolling quota usage. This needs alerts. It's your early warning system to prevent developers from getting blocked.
Proactive, not reactive. Got it. What about adoption?
An adoption profile dashboard. This could show things like the terminal type breakdown, are people using it more in VS Code or somewhere else, and a table of requests per user. This helps you spot power users, maybe learn from them, and also identify users or teams who might need more training.
Finding the champions and those who need help. Smart. And performance.
Absolutely. Command duration, probably tracked at the P95, the 95th percentile. If that number starts creeping up, developers are waiting too long. And alongside that, the overall request success rate. If that dips, you know you've got reliability issues to investigate using those error logs we talked about.
P95 duration and success rate. Key health indicators.
For sure. And finally, a strategic one. A breakdown of tool types being used. Are developers trusting Claude mainly for simple read tasks, or are they using it for complex edit suggestions or bash commands? That tells leadership where the real value is being perceived and where to invest next.
Okay, that paints a really clear picture. Now, one practical question. The article mentions enabling this via environment variables like Claude Code Enable Telemetry 1. That's fine for one person, but scaling that to hundreds of developers seems tricky.
It would be impossible to manage individually. That's why centralized management is critical for any real deployment. The source points out that administrators can and should enforce these settings using a managed settings file.
Ah, okay, so like a central config file pushed out to all machines?
Exactly. The example given is managed settings.json on Windows. This way, telemetry isn't optional, it's a standard, consistently applied across the whole organization. That's how you get reliable fleet-wide data.
Right, that makes sense for enterprise scale. So wrapping this up, it feels like we've gone from that opaque, black box AI tool.
to something transparent and measurable. By using OpenTelemetry for standardized data collection and a platform like SigNoz for analysis and visualization, you can actually see what Claude Code is doing, how much it costs, and how effective it is.
And the takeaway from Carthy's article seems to be that this kind of observability isn't just a nice to have for AI tools, it's becoming essential for managing costs, for optimizing performance.
And for making informed decisions about how AI fits into your engineering culture. It's about scaling responsibly with actual data, not just hype.
Which leads to maybe a final thought for everyone listening. We talked about that Code tool decision metric, showing developer trust through acceptance rates. So here's the question. If your dashboards consistently show a high rejection rate for suggestions from your most expensive, most powerful AI models, what does that really tell you as a leader about your AI strategy?
Hmm. It suggests that maybe just throwing the most expensive model at the problem isn't the answer. If developers don't trust the output enough to accept it, its power is wasted. Maybe prompt engineering is off, maybe the model isn't right for the task, maybe simpler is better. It forces a deeper look beyond just usage stats.
Food for thought indeed. Hit like and subscribe if you like the content. See you next time.